So now, continuing the examples in the increasing and the decreasing of the function, they have given one question is like, prove that a logarithmic function is strictly increasing on strictly increasing on 0 comma infinity. So we have to be checked, we have to be proved that the logarithmic function is increasing on this interval, that is open interval 0 comma infinite. So logarithmic function means we have to take that f of x is equal to 1 log of x. So increasing means what? F dash of x should be greater than 0. First find out for the f dash of x is nothing but 1 divided by x. So the condition for increasing is what? F dash of x should be greater than 0. Then what is f dash of x? That is 1 divided by x is greater than 0. So here 1 by x is greater than 0 means it is increasing from 0 to infinite if I take the real line. So this is positive 0 to 1 to up to infinite. It is increasing from 0 to infinite. Then we can see that x is belongs to 0 comma infinity. So we have been proved that the logarithmic function is increasing function for the interval 0 comma infinity. Okay. So the next one example, prove that. So the next one example is prove that the function f given by f of x is equal to x square minus x plus 1 is neither strictly increasing nor decreasing on minus 1 comma 1. So we have to prove that the given function is neither increasing nor decreasing in this interval. Okay. So again we have to from the f of x is nothing but x square minus x plus 1. Is it? Then f dash of x is nothing but 1. That is 2x minus 1. So condition for increasing is what? So the condition for increasing is what? F dash of x will be greater than 0. What is f dash of x? That is 2x minus 1 is greater than 0. Then 2x is greater than 1. Then x is greater than 1 divided by 2. So x is increasing from 1 divided by 2. It means x is belongs to, that is open interval 1 by 2 comma infinite. So it is not being increasing in the interval again minus 1 comma 1. So that we have been proved for the increasing. Next it's about the decreasing. What is the condition? That f dash of x should be lesser than 0. Again, what is the f dash of x? That is 2x minus 1 is lesser than 0. Then 2x is lesser than, 2x is lesser than plus 1. Take this minus 1 to the RHS. Then x is lesser than 1 by 2. So x is decreasing from 1 by 2 means it is going towards the negative side up to minus infinite. It means x is belongs to minus infinite comma 1 by 2. Again it is not being decreasing in the interval minus 1 comma 1. Now we can say that the function is neither decreasing nor increasing in the interval minus 1 comma 1. Okay. So this is we have been proved for the second one example. The next one example is like the next one example is like find the values of x for which find the values values of x for which y is equal to x into bracket x minus 2 whole square, x into bracket x minus 2 whole square is an increasing function. Is an increasing function. Is an increasing function. So we have to be sure. Either you can consider this one as the f of x also, no problem. Y is nothing but we can consider as the f of x. The f of x I can write it as that is x into bracket x minus 2 whole square. So what is the condition for increasing is what? That is f dash of x should be greater than the 0. Okay. So what is the f dash of x then? Then it is x square into of x. But x is in the form of u into v. First I keep the x as it is. Then the differentiation of x is 1. Minus 2 is 0. That is x into 1. Next plus. Keep the x minus 2 as it is. Then the differentiation of x is 1. Okay. So this is 2 into bracket x minus 2. And here this is x plus x. That is 2x minus 2. So now I will take the 2 as the common multiple. Then 2 is 4 x minus 1. Here if I take the x as 2 as the common multiple, then what remains? X minus 1, then x minus 1. This is the f dash of x. So here we have the three critical points like x minus 1, x minus 2. Now what I will do, f dash of x is equal to 0. Then what we have, that is 4x x minus 1, x minus 2 is equal to 0. When I send this 4 to the other, then I will set it 0. X minus 1, x minus 2 is equal to 0. Therefore, x value is x is equal to 1 is 0, 1 is plus 1, 1 is plus 2. So we have to be find out for the values when it is increasing function. We have to be find out for the value when it is increasing function. So here we have the x and the three critical points for the three critical values. So now what I will do for f dash of x, what I have the f dash of x is f dash of what I have the f dash of x is 4 into 4 x minus 1 x minus 2. When I put, so already I have been solved this type of the example previously. When I put x is equal to 0 in this equation, so 0 into any number is again f dash of x is, that is again 0. It means what I will get here as the positive value. When I put x is equal to 1, then it is 1. That is the 1 minus 1. 1 minus 1 is 0. So put x equal to 1. So when I put x is equal to 1, again what I get the value. So here also I can get it as the one that f dash of x is 0. It means I get all the positive values here. So it is increasing means what? When I take the real line, so it is increasing, it is from 0, 1 and 2 up to infinite. So it starts from the 0, then 0 to 1 and the union, that is 2 to infinite. Then I can write it as that x is belongs to 1, that is 0, 1 union 2, infinite. I can write this one. Okay. So this question is also being rarely asked in the examination, but somehow we have to do this one. Okay. So the next one. Okay. So I will give one more example as the homework here. So that you have to be solving home. The one condition I will give. If you do not solve that, you can ask me. Okay. So there I will give one homework. It as a homework. Let I be any interval. This is homework. Let I be any interval. Let I be any interval disjoint from minus 1 comma 1. Prove that function f given by function f given by f of x is equal to x plus 1 divided by x is strictly increasing on I. Is strictly increasing on I. So this is how your example that you have to be solved in home and you have to be sure. Okay. So this is about the what? Increasing and decreasing. This is one of the concept in the what? The applications of the derivative. Okay. So the next one type of the concept is what? The next one type of the concept is what? That is maxima and minima. Maximum and minimum. Maxima and minimum. Maximum and minimum. So in this concept we are going to solve some different examples. Okay. So the first one is about maximum and minimum values of the functions. Maximum and minimum value of the function. Maximum and minimum values of the function. Okay, so I will take for the maximum value. Maximum value of function. So when we can say that the function is said to be a maximum, when I take the function, let f of x is defined on I. Is defined on interval I. Such that when f of x is defined on interval I is said to be a maximum, is said to be maximum, is said to be a maximum if there exists C, if there exists C on I such that f of c is greater than f of x. There exists a point C on I such that there exists a point C, you can say point C on I such that f of c is greater than f of x is said to be a maximum, is maximum value of f of x, maximum value of f of x. Okay, so here we can say that f of c is greater than f of x. Here we have to do some heading. Then f of c is maximum value of the f of x. Then and c is called maximum value point, you can say value of point of f of x. Again I am going to explain this one. So here we can say that what is mean by the maximum. So here what is mean by the maximum value of function? When function is defined on interval I is said to be a maximum if there exists a point C on I such that when f of c is greater than f of x. When f of c is greater than f of x, then we can say that f of c is maximum value of f of x, and c is called maximum value point of f of x. The next one is about the what? Minimum value of function. Minimum value of function. The same condition. Let f of x is defined on I on interval I then there exists C on I that f of c is lesser than f of x, then f of c is minimum value of f of x, minimum value of f of x, and c is called, you can say that, point of minimum value, point of minimum value of f of x. So by solving one example, you will come to know what is meant by the maximum value of function and what is meant by the minimum value of function. But you should have to remember, when f of c is greater than this function, when f of c is greater than f of x, then it is a maximum. When f of c is lesser than f of x, so this f of c is minimum value. When f of c is greater, it is maximum value. When f of c is lesser, then it is minimum value. Okay. So by solving one example, you will come to know what is meant by the maximum value and minimum value of the function. Okay. So find the maximum and minimum values of the function. Example. Find the maximum and the minimum values of the function. Values of function of following. The first one example, we have given it like f of x is equal to. The first one example, f of x is equal to 2x minus 1 whole square plus 3. 2x minus 1 whole square plus 3. Okay. So already we know that the square function is always greater than or equal to 0. The square function is which one here? 2x minus 1 whole square is always greater than or is equal to 0. Already we have been studied. The square number is always greater than or equal to 0. Now what I will do? Here what I have? So here what is missing? Plus 3 is missing. So when I add the plus 3 to the LHS as well as RHS of the inequality, so here 2x minus 1 whole square plus 3 is greater than or equal to 0 plus 3 means what is 2x minus 1 whole square plus 3 is your f of x is greater than or equal to 3. So it means here what you get, f of x is, that is f of c. So here it means what? The f of c is lesser than, f of c is lesser than, f of c is lesser than f of x. It means the minimum value of f of x is what? 3. We can say that the minimum, because f of c is lesser than the f of x. By the condition already we know the minimum value of f of x is 3. When it is becoming 3, minimum value 3 over after 3. So look here, square number in number, that is 2x minus 1 whole square is equal to 0. Because already the 3 is when it is becoming, function is told in 2x minus 1 whole square. The function already told in that square function is always greater than or equal to 0. So other function not told. When it is becoming 3, when square greater square root 0, then 2x minus 1 is equal to 0, then 2x is equal to 1, then x is equal to 1 by 2. So when you put x is equal to 1 by 2 in this equation, so 1 by 2 into 2 get cancelled, then 1 minus 1 is 0, so 0 plus 3 again what you get, that is 3. So the minimum value of the function is 3 when x is equal to 1 by 2. We can say, again I am repeating this one. So whenever we give the square function and they have said us to find out the minimum and the maximum value of the function, so whenever it is a square, it should be greater than or equal to 0. So now function you have to consider one name, that is 2x minus 1 whole square greater than or equal to 0. Always square number is what? Greater than or equal to 0. So ಈಗ ನಾನು ಈ ಫಂಕ್ಷನ್ಸ್ ಬೇಕಾದ್ರೆ ನಾನು ಏನು ಮಾಡಬೇಕ್ರಿ? I have to add the plus 3 to the both side. So when I add the plus 3 to the both side, then I get the LHS as the what? F of x, then f of x is greater than or equal to 3. But here f of c's value is lesser than the f of x. So that's why you can say that this is the minimum. ಯಾಕಂದ್ರೆ ಇಲ್ಲಿ f of c ಸಮ ಪದ್ಧತಿ ಎದಕ್ಕಿಂತ f of x ಗಿಂತ, and f of c is lesser than f of x, then the minimum value of f of x is 3. ಈ 3 ಯಾವಾಗ ಸಿಗ್ತೈತಿ? ಯಾವಾಗ ನಾವು ಫಂಕ್ಷನ್ ಒಳಗ ಫಂಕ್ಷನ್ ಅನ್ನು equal to 0 ಕಂಪೇರ್ ಮಾಡ್ತೀರಿ, then you get the minimum point of f of x is what? 1/2. The next one example, ಇನ್ನೊಂದು example ಬಿಡಿಸ್ತೇನೆ, ಇನ್ನೂ ನಿಮಗೆ ಐಡಿಯಾ ಬರ್ತದೆ. The next one example, f of x is equal to minus 1 of x minus 1 whole square plus 10. Okay, so ಇಲ್ಲಿ ನಾವು square number ಕೊಟ್ಟಾರ. Whenever they provide the square number, already we know that it is always greater than or equal to 0. But here in this function, the square number is having a negative. Or negative ಬಂದಾಗ ಏನಾಗ್ತದೆ? Minus multiply ಮಾಡ್ತಾನೆ. Then minus of x minus 1 whole square is lesser than or equal to 0 ಆಗಿರ್ತದೆ. Because negative number is always lesser than 0. So now ಈ ಮೇಲಿನ function ಸಿಗಬೇಕಾದ್ರೆ ನಾನು ಏನು ಮಾಡಬೇಕು? I have to add the plus 10 to the both sides, then minus of x minus 1 whole square plus 10, then 0 plus 10 is 10. So ಇದೇನಾಯ್ತು ಇದು? This is nothing but f of x is lesser than or equal to 10. ಅಂದ್ರೆ ಏನಾಯ್ತು? This is nothing but what you have? F of c. It means f of c is greater than f of x. Then we can say that the maximum value of f of x is what? 10. 10 ಯಾವಾಗ ಸಿಗ್ತದೆ? ಈ ಫಂಕ್ಷನ್ ತಗೋರಿ. When x minus 1 whole square is equal to 0, because greater than or equal to 0 ತಗೊಂಡ್ರಿ, 1 is equal to 0. Square root condition ಏನಾಯ್ತು? 0. Then x minus 1 is equal to 0. It is the maximum value of f of x is 10 when x is equal to 1. This is what? The maximum value of 10 when x's value is having 1. So this is how we are going to be solve the maximum and the minimum value of the function. Okay, so one more is there, the third one example. This is little bit a different example, the third one. F of x is equal to the third one, that is 9x square plus 12x plus 2. But here complete square number, ಈ ಯಾವುದು ನಿಮ್ಮೊಂದ complete square number ಇಲ್ಲ. ಇದನ್ನ ನಾನು ಏನು ಮಾಡಬೇಕು? ಈ quadratic equation ಅನ್ನ complete square number convert ಮಾಡ್ಬೇಕು. ಹೇಗಂದ್ರೆ by taking ax square plus bx. So already we have been, you people have not been studying. I think you have been studying for the when the function is in the quadratic equation form, to find out for the what? To find out for the what? In multiple function. ಅಲ್ಲಿ ನೀವು ಇದನ್ನ ಕಲ್ತಿರಿ. 9x square plus 12x. ಇದನ್ನ ನಾನೇ ಮಾಡ್ತೀನಿ. a plus b, ಯಾಕಂದ್ರೆ in between one big sign we have plus we have. So ಅದಕ್ಕೆ ಏನು ಮಾಡ್ತೀನಿ? a plus b whole square is equal to a square plus 2ab plus b square form ಅನ್ನು ಕನ್ವರ್ಟ್ ಮಾಡ್ತೀನಿ. So 9x square is complete square number. It means 3x whole square, but the a value is what? 3x. 2 is compulsory. Again a value is 3x. So here what I want to get? ax square plus bx. ನೋಡ್ರಿ, 2 into 3 6x ಆಯ್ತು, ಬಟ್ ಇಲ್ಲಿ ಏನೈತಿ? 12x ಆಯ್ತು. So 2 3s are 6. It means b value is 1 2. So this is 2, this is a, this is b. ಮತ್ತೊಂದು ಏನೈತಿ? ಪ್ಲಸ್ b ಸ್ಕ್ವೇರ್ ಐತಿ. ಇನ್ನೊಂದು ಏನು ಮಾಡೋದು? ಕಂಪಲ್ಸರಿ ಮೈನಸ್ b ಸ್ಕ್ವೇರ್. ಯಾಕಂದ್ರೆ ಈ ಇಕ್ವೇಷನ್ ಗೆ ಬ್ಯಾಲೆನ್ಸಿಂಗ್ ಆಗಬೇಕು. ನೋಡಿ, plus 2 square minus 2 square ಹೋದ್ರೆ ಮತ್ತೆ ಏನು ಸಿಗ್ತೈತಿ? The same condition. It means a square plus 2ab plus b square. Perfect square it means 3x plus 2 whole square. This is minus 1. Therefore, what is 9x square plus 12x plus 2 is, that is 3x plus 2 whole square minus 4 plus 2 minus 4 plus 2. So here it is what? 3x plus 2 whole square minus 2. So now it is what you are f of x. So here also we get the what? The perfect square. Therefore f of x under that is 3x plus 2 whole square minus 2. So therefore already we know that 3x plus 2 that is a perfect square number is always greater than or equal to 0. Now ಏನು ಮಾಡಬೇಕು minus 2 ಅನ್ನು ಅಕಸ್ಮಾತ್ ಸ್ಕ್ವೇರ್ ಮಾಡಬೇಕು. Then 3x plus 2 whole square minus 2 0 minus 2 is again minus 2. ಇದೇನಾಯ್ತು ಇದು f of x minus 1. F of c ಏನಾಯ್ತು that is lesser. f of c is lesser than f of x. Therefore ಏನಾಯ್ತು the minimum value of f of x is what? Minus 2. When value minus 2 ಸಿಗುತ್ತದೆ ಈ ಫಂಕ್ಷನ್ ಏನು ತಗೊಂಡ್ವಿ 3x plus 2 whole square is equal to 0, then 3x plus 2 is equal to 0, then 3x is equal to minus 2, then x is equal to minus 2 by 3. ನೀವು ಯಾವಾಗ x ಇದ್ದನ್ನ ಈ ಫಂಕ್ಷನ್ ಒಳಗೆ minus 2 by 3 ತುಂಬಿರಿ ಅವಾಗ ನಿಮಗೆ ಏನು ಸಿಗ್ತೈತೆ that is minus 2. So this is how we have been solved for the what? The maximum and the minimum values of the function. The remaining examples will be continued in the next class. Okay. So by pausing the video, you have to note down the notes. If you did not get this the concept,